So the null hypothesis should go on this statement wherein there is no difference between the observed and the expected values. So that's why they are too close with each other, because there is no difference. Okay? Therefore, your alternative hypothesis now would be against positive 4, that there is difference between the observed and the expected values. Did you get that? Okay, so let's move on. So how are we going to compute for the chi-square? So this is actually the computation. Can you Okay, so this is now the computation. So this is how are you going to compute for the chi-square. So the first one would be looking for the expected phenotype equation. Okay, I forgot to place there the phenotype, but it should be written there. Okay, so you are actually expecting for 3/4. What phenotype? What phenotype again? White. And you are actually expecting for 1/4 purple. Okay, so you should write the phenotype. Kalimutan ko na. It should be 3/4 white. So you have to write here white. And then 1/4 purple. Did you get that? Okay. So the first thing to do, because if you're going to look at this table, you cannot fill in this table yet. Based on the given. What are the given here? The given are the expected phenotype equation from the cross, and also you are being given with the observed values. So in the problem, you are actually given that they actually observed 219 white and 110 purple. So only the first two columns can be filled in using the given. Did you get that? Okay. So this is 3/4 white, 1/4 purple. So 219 white, this is what they observed, and 110 purple. The first thing to do is to get the total number of progenies. Okay? So I would refer to the total number of progenies. So 290 plus 110. So you will get here 400. That's why you need a calculator in your exam. Okay? So how are you going to get the expected value of the progenies? Okay? You have here the n, makinig ka buti, 400 divided by the denominator of the expected ratio, which is 4, times the numerator, which is 3. So you get here 300. So you are actually expecting for 300 progenies, which will get the white color. Did you get that? Okay. Next thing to do is to get for the purple. So 400 divided by the denominator, multiplied it by the numerator, so you get here 100. So still, you have a total here of how many progenies? 400. But you're going to test how close is this 300 to your 290. Is there a significant difference in between 300 and 290? Is there a significant difference between 100 and 110? So the third thing to do is to get the deviation. Deviation is actually equivalent to observed minus expected. So just plug in the values. The observed is actually 290 minus 300, so you get negative 10. 100 minus 110 minus 100, so you get here 10. Okay. Next thing to do, you get the deviation squared. Okay. So you have here negative 10 times negative 10. So you have positive 100. Here you have here 10 by 10 times 10, you have 100. Okay, the next thing to do is to get the d-square deviation square over expected. Because the chi-square is equivalent to the summation of your d squared over expected. Over expected, chi-square is equal to the summation of your d squared over expected. Did you get that? Okay. So 100 over, you are actually expecting for 300. So you get 0.33. And then, you have here 100 divided by 100. So you get 1. So get the sum or the total of that. So that is actually equivalent to 1.33. Did you get that? So that is already your chi-square calculated. Does it make sense? Does it make sense? No. Ano naman kung meron kang calculated na 1.33? How are you going to interpret this one? What is the meaning of chi-square equal to 1.33? Okay, so the next thing to do in statistic, you have to compare this one on the critical value of the chi-square. The x-squared critical can be found on the table. Have you seen this one? Where you have the F table, you have the T table. Can you still remember? No. Okay. In the chi-square critical, what you need, there are two major requirements here. You have to know the degrees of freedom. So the first one is the degrees of freedom, or the DF. We call this one as the DF. And the DF is usually equal to n minus 1. N referring to the number of categories. So in this regard, we have how many categories? We have 2, white and purple. Okay, so therefore our DF is actually equivalent to 1. Did you get that? Okay, so another thing to remember when you are looking on the chi-square critical is what we term to as the level of significance. Okay? So level of significance. Na nga pala kayong bias na. Okay, so with regards to the level of significance, so for example, you will be given 95% level of significance. Okay? You can compute for the alpha given this one. So if this is 95% level of significance, it would actually mean if you're going to minus that for 100, you still have 5% room for error. Okay? So you still have here 5% room for error. So you're not 100% sure with the critical value because you still have 5% error here. So you can compute for the alpha. The alpha is always on its decimal form. So if there would be 95 level of significance, the alpha would be referring to the room for error. So the alpha is now equal to 0.05. Did you get that? Okay, so how are we going to look for the table? Okay, so you have the degrees of freedom on that side. Okay, so 1, 2, 3 up to 10. And then you have here the alpha. So this is actually your alpha. Okay? So in this regard, if we're going to have here a DF, which is actually equivalent to 1, so therefore you have here 1 degrees of freedom. And then your alpha is 0.05. Therefore, the value of your chi-square critical is equivalent to 3.84. Okay, 3.84. Does it make sense now? Yes. What is the sense? What is the sense knowing your calculated is 1.33 and your chi-square critical is 3.84? Does it make sense now? Not yet. It's because you have to make a decision. So in biostat, there is what we refer to as decision. Okay? Your chi-square, if the chi-square, if the chi-square calculated is greater than your chi-square critical, what are you going to do? Reject your HO. If you rejected your HO, have to accept the HA. Okay? If the chi-square calculated is less than the chi-square critical, you have to accept. In this regard, let's compare. Your chi-square here, the chi-square calculated here is 1.33, which is critical, which is equivalent to 3.84, which is relatively larger. For the critical, what is now your decision? Accept. Does it make sense? Oh, what is the sense now? Not yet. Because you need to have